Hello everyone, my name is Mikhailo Bagmut and I am presented an article, a method of corresponding single errors of data presented in the residual class system by Viktor Krasnobaev, Alexander Kuznetsov, Mikhailo Bagmut, Yelizaveta Lazareva, Tetiana Kuznetsova. Talking about relevance, it is known that the properties of the non-positional number system in the residual classes, namely independence, equality, and low bitness of the residuals, the totality of which determines the non-positional code system, provides higher than in the positional binary number system user performance of the computer system designed to process data presented in integer form. The greatest efficiency from the use of the RNS is achieved in the case when implemented CS algorithms consist of a set of such numerical arithmetic operations as addition, multiplication, and subtraction. It is known that the use of such properties of the RNS created on the use of one of the possible residual classes modulo a prime number ME, the complete system of the list non-negative residuals 0, 1, 3, etc. ME-1, such as independence, equality, and low bitness of residuals AE, which determine without redundant NCS of data provides high user performance in the implementation of computational algorithms, consisting of a set of arithmetic modular operation and high reliability of the CS. In addition, the necessity to ensure the required degree of reliability of calculation requires the development and implementation of methods for monitoring, diagnostics, and error correction of data presented in the RNS different from the methods used in the ordinary binary PNS. The necessity to access the reliability of calculation of the CS in the RNS requires the introduction of new control methods in non-positional machine arithmetic and the correction of data errors different from the methods used in conventional binary PNS. Note that firstly, all methods of control, diagnostics, and error correction in RNS are based on the specifics of the implementation of positional operations in a given non-positional number system, which requires knowledge of the magnitude and sign of number represented by the redundant non-positional code structure of the NCS. Secondly, control methods in the RNS are the further development of controlling the modulus in the PNS method. Indeed, from the point of view of informational reservation codes in RNS provide further improvement of the known arithmetic many residual codes. The purpose of the article is to develop a method for correcting single data errors presented in the residual number system, as well as to study the possibilities of its practical use. In general case, the process of correcting data errors in the RNS as in the PNS consists of the three stages. The first stage is data control, determination of the correctness or incorrectness of the original redundant NCL. The second stage is a misdiagnostics of a wrong RNS number, determination of one distorted residue. The third stage is the direct correcting of the wrong residue A of the number A to correct residue. The process of data error correction in the RNS is carried out as in the PNS due to the introduction of additional information redundancy. The article discusses the method for correcting single errors of data presented in the RNS when introducing a minimum additional informational code redundancy into the NCS. In this case, MCD will be equal to the value D minimum. The article shows that in some cases in the RNS with the value of D minimum, it's possible not only to detect but also to correct single errors. The essence of this method consists in the possibility of correcting single errors of the data presented in the RNS with the introduction of minimal information redundancy by implementing relation. Experiments and results. Table 1 shows orthogonal basis BE of RNS. Table 2 and 3 give the entire set of possible incurrent code words, which is formed by modeling all possible single errors for correct numbers respectively, for each of the RNS bases. Table 2, the set of possible incorrect code words for the correct number with the single errors. A set of non-private working bases for a given RNS and set of private orthogonal bases are presented respectively. The table 3 shows the set of possible incorrect code words for the correct number A with single errors. In conclusion, the essence of the correction method considered in the article consists in the possibility of correcting single errors of the data presented in the RNS with the introduction of the minimum information redundancy by implementing the presented mathematical ratio. This is due to the fact that in contrast to the arithmetic correction codes used in the PNS, the arithmetic correction codes in the RNS have additional correction capabilities. Thus, the presence of both primary and secondary information redundancy in the NCS presented in the RNS in some cases can provide the possibility of correcting single errors when the MCD is equal D minimum. However, in this case, additional data processing procedures are required to correct single data errors. In particular, this is achieved by applying, in addition to the information reservation, also time reservation. The examples of the performing the data correction operation for a specific RNS given in the article confirm the results of theoretical studies. The results obtained can be used in various computer applications. In particular, the range of the practical tasks may include the construction of promising computer components operating in the residue number system, parallelization of computational process, increasing the reliability and fault tolerance of computing devices, and much more. Thank you for attention.